Do you remember the experiment where 8 fasting male subjects were given a dose of alcohol, and then the alcohol was measured in their bloodstream over several hours? It turns out that the formula for the alcohol in the blood fitted to the average of the 8 male subjects is given by C of t here, and it turns out to be 0.225 t e to the minus 0.0467 t. C, the blood alcohol concentration, is measured in milligrams per milliliter, and t, time, is measured in minutes. And the question asks us if the maximum value in the first hour is above the legal limit. And so we have t going from 0 to 60 here, and we have c on the vertical axis. And we'd like to know if the value of c goes above 0.08 milligrams per milliliter. So to calculate the maximum for c over the closed interval 0-60, we need to evaluate c at critical numbers and endpoints. So let's look at the critical numbers first. We want to set c prime of t to be 0. If we want to calculate c prime, we can see that we have a function f here and a function g here. And the formula for c prime will then be f g prime plus f prime g. And so let's go ahead and calculate that. This is going to be 0.0225 t times the derivative of g, which will be minus 0.0467 times e to the minus 0.0467 t. And then we'll have f prime, which is 0.0225, and we'll multiply that by g, which is e to the minus 0.0467 t. And you'll notice these two are found in the last term and also in the first term, so we can pull out a common factor and write it as 0.225 e to the minus 0.0467 t times minus 0.0467 t plus 1. And we want to set that to be equal to 0 to find a critical number. And this first term, though, is going to be positive because the domain of the exponential function is the positive real numbers. And so it must be that this second term is equal to 0. And so we can solve that for t to get t is equal to 1 over 0.0467, which is about 21.4 minutes. That'll be our critical number. We also have endpoints, and those are t is equal to 0 and 60. So if we calculate the values of c for each of these, we start with the case where time is equal to 0. If we plug into the formula for t, we see when we put in time is equal to 0, we're going to get c of 0 is equal to 0. When we plug in 21.4, it turns out that we get a value of 0.177. And at 60, we get a value of 0.0819. And again, this is milligrams per milliliter. So if we look at the graph of the function now, at 0, it's equal to 0. At t is 21.4, it's equal to 0.177. And at t is equal to 60, it's equal to 0.0819. And so the graph of the function looks something like this. And we see we have a maximum at time is equal to 21.4. And indeed, this maximum is above the legal limit of 0.08 milligrams per milliliter. In actual fact, it's still above the legal limit at time equals 60.